This is Britt Caswell with another example video. On today's video, I'm covering example 5 from lesson 9-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to write the factored form of a quadratic function. Sometimes we call this the intercept form. Just here's like a nice little graphic about it. Alright, and so what we're doing is we're taking a graph and trying to write the equation for that graph. And really, there's 3 steps to it. So the first thing that we're going to do is we're going to find the x-intercepts. So you could see right here, my 2 x-intercepts are -5 and 1, which is where they're crossing right here and right here. All right. So step 2, sorry, just making sure that I have enough room here. So step 2 says to write a quadratic equation in factored form using those x-intercepts. All right, so that's what I'm going to do. I'm going to say y equals a times x plus 5 and x minus 1. Remember, when we do the zero product property, right, we take this and set it equal to 0. And so what I like to do, or the way that I like to think about it, is I'm taking these and solving it to get 0 alone, or to get it equal to 0. So I'm kind of undoing that. So I could add 5 here, and that'll give me the factor x plus 5 equals 0. It makes it a little easier to see. Here I would subtract 1 to move it over, right? Oops. And so that would give me x minus 1 equals 0. So that's where these factors are coming from. But many students just think to flip the sign. So whichever way you feel most comfortable with, you do you, boo. So now step 3 is requiring us to find another point and using it to solve for a. Now a lot of times you can kind of cheat this a little bit. Remember, a is how much the graph moves up or down when you go 1 unit to the side from the vertex. So on this one, it looks like my a is a 1. But what if my a turns out to be like 1.013? Is our graph detailed enough for us to see that difference? No. So to be sure that I'm getting that exact value, I'm going to take this point and plug it in for my x and y's just to verify what a will be. All right? So my y value for this point is -9. And then I'm going to fill in my x's. So my x's are -2. All right. So now we're going to start simplifying. So I have -9 equals a times -2 plus 5 is -7. And, oh, what? Missy, shame on you. -2 plus 5, that is 3. And -2 minus 1 is -3. So if I do that multiplication, 3 times -3 is -9. And it's being multiplied to a, so I'm actually going to divide that -9 out. And sure enough, I get 1 is equal to my a value. And so my final formula, or my final equation, would be y, or f of x, equals 1. So I don't have to fill in a 1 at all, right? It's just a 1 times x plus 5, x minus 1, like that. Okay, so now let's go ahead and let's do that same thing here in the try it. All right, so our first step is to find our zeros. So I see it here at 3 and here at 9. So my equation is going to start out by looking like y equals a times x minus 3 times x minus 9. Now I'm looking for my vertex, right? It looks like my vertex is at 6, -9, so that's what I'm going to plug in here. All right, so I get -9 equals a times 6 minus 3, 6 minus 9. So 6 minus 3 is 3. 6 minus 9 is negative 3. So we're getting kind of the same thing as we got on the last one, right? Now here, the a is being multiplied to the negative 9, so I'm dividing by negative 9 on each side. And so again, my a value is 1. So my final equation will look like y equals a, which is 1, times x minus 3 times x minus 9. So there we have it, guys. That is how to write a factored form of a quadratic function. Until next time.